Electrostatic potential energy. So we talked about the work done by the electric field on unit positive charge, 1 coulomb of positive charge, and then also on the charge q, and during the motion in the electric field what happens. And we also knew about the work required to be done by the external force against this electric field if it is brought from some infinity to the electric field, or it is moved from some point P to Q, in which the motion of charge is without acceleration only. So because there is no acceleration, that means the velocity remains constant and the kinetic energy doesn't change. But the work done by this external force is stored in what form? It is stored in the form of potential energy of that charge. So what electric potential energy becomes? Electric potential energy, the work required to be done against the electric field, the work required to be done against the electric field in bringing a given charge, say Q, from infinite distance to a given point in the electric field is called electric potential energy of that charge at that point. So the motion without acceleration is implied in this definition. That is, work required to be done. So again, if this is a charge, okay, now this charge, we are bringing this given charge from infinite distance to some electric field, say this is the electric field, and we are bringing it here from infinite distance to somewhere here. Now the work required to be done against this electric field to bring this from infinity to this point is stored or is called the electric potential energy of that charge at that point. And from the definition of electric potential energy and the electric potential, we can write the electric potential energy of charge Q, say at some point P, because we are bringing it from infinity to some point P, this charge Q. So from infinity to P will integrate, and because there is some charge Q, it is not 1 coulomb, so we have to multiply this Q. E dot dr we already know. So E dot dr, Q is the charge which we are bringing in some electric field. So let us take this Q out, minus sign is the work done against the electric field, that is why we have negative sign. E dot dr. And what is this? Infinity to P, integral of E dr, we know that this is nothing but Vp. Okay, we are bringing at some point P this charge. So this is potential at point P. And we can also say the electric potential at point P as the electric potential energy of unit positive charge plus 1c coulomb at that point. That means the electric potential at a given point is equal to C. This is only electric potential. So electric potential at a given point is equal to electric potential energy of unit positive charge at that point. Let us clarify more of this if you don't understand. When we bring a charge Q, say a unit positive charge, from infinite distance to the given point, or when we move it from one point to another, say we are bringing it from here, or if it is already in the electric field and we are moving this charge from this point to this point, say, right, we are relocating it, then the position of the charges or the sources, or the position of the sources producing the field are not changed. It doesn't change. The absolute value of, absolute means the magnitude of the electric potential energy is not at all important, only the difference in its value is important. As we saw in the electric potential, that is, we are interested in potential difference, not in potential at some point. So this is not important here also. Potential energy, the absolute value of electric potential energy is not important. Only the difference in its value is important. So in moving a charge Q from point P to Q, this is a charge Q at point P, we are say moving it to some point Q. Without acceleration, the work done or work required to be done against the external force, this shows the difference in the electric potential energy. That is, it has potential energy here at P, and we are taking it to Q. So what is the difference? UQ minus UP for that charge. So UQ minus UP by definition becomes minus Q. From P to Q, we are taking it from P, and this P and Q are the initial and final position. This is EDR. So the electric potential energy of this entire system of the sources producing the field, that is whatever is included in producing that electric field, and the charge that is moved, this charge for someone or some configuration, and means they are in one configuration. When the configuration changes, the electric potential energy also changes. That is, when the distance between them is, say, R, it is one configuration. And if we say that R is changing, the configuration is also said to be changed. And therefore, the electric potential energy of the system is also said to be changed. It will vary because R has changed, the distance has changed. We are moving from this point to this point. If we move it from P to, say, K, it will be different. But the condition of the source which are producing the field, they are not changed, because we are just changing the position of Q, but the electric field is not changed. The entire change in the electrical potential energy, which is experienced by this Q only, this charge only, which we have moved. So what we are able to say here, we are able to write UQ minus UP, this, as the difference of the potential energy of this charge Q only. That is why we have mentioned and we have said that the potential energy of charge Q, right, for this equation, previous equation, as you remember, this one, this equation, we have said that it is electrical potential energy of charge Q. This is electrical potential energy of charge Q and positive and potential energy of unit positive charge, right? Then we followed it.